Most likely, this will be the last video in this playlist about LaTeX typesetting, except something else comes up and I have to do another video. So here I'll be talking about something that will interest the chemists who work with chemical equations. So this video is about working with chemical equations in LaTeX. Okay. All right. So this lesson explains how to produce clear publication-ready chemistry notation using the mhchem package. Well, we may end up not using that. Well, let's see how it goes. Using the mhchem package along with siunitx for units, it covers writing formulas and reactions in plain text that render with correct subscripts and superscripts, adding states such as solid, liquid, gas, and aqueous, and indicating charges, stoichiometric coefficients, and reaction direction or equilibrium. So you learn how to place conditions like heat, light, catalyst, temperature, pressure, and solvent above or below reaction arrows, how to show isotopes with mass and atomic numbers, and how to align multi-step mechanisms and long equations for readable layouts. The lesson also highlights consistent typesetting of concentrations, temperatures, and pressures, plus simple patterns for mechanisms, equilibrium expressions, and balanced equations suitable for articles, theses, slides, and exams. So let's go ahead. I mean, for if you have done chemistry before, if you've been in a chemistry class, you know what those things look like, right? So I'm just going to go ahead and first look at a minimal preamble. So the smallest level of things you need to get in place to get this moving. Okay, so I'm just going to copy this straight to overleaf and try to explain anything that requires explanation. So let's open this. So I'm going to go under LaTeX typesetting 2 and I'll let me name a file, new file. I'll call it Chem1 because I want to use Chem2 for the mini project under this. So I just paste this now, then it's going to be rendered automatically. So you're just going to have hello chemistry here because that's all we have right now. So see what's happening. We need document class article, use package up Greek, use package geometry. Of course, these are regular stuff. Use package AMX math for better display maths. Then use package version equals for mhchem. So from this mhchem now you can have \CE and \PU. That's chemical formulas, reactions, and units light. Then use package siunitx for robust units. Then you can use package modules equals reactions, and you have chemacros, which is more focused. Then you have SI setup. So per mode is symbol, separate uncertainty is true, right? And then we just have hello chemistry. I mean, we're just starting out. Let's see other things we can do here. Okay, I think I want to move this further so I can easily pick on LaTeX. Okay, so I come back here now, and then we have using CE and inline display. Using CE inline and display. Okay, look at this now. So this CE in particular is the key thing we have when we work with chemical symbols, especially when we use CE, when we use this package, this MHCHEM. That's the most important package when you do chemical symbols. So here now you have inline. Water is so this C will make sure that this H2O just doesn't come out the way it is. So to now be H sub 2O, as it should be. And sulfate is SO42, the way everything should really appear in chemistry. So that CE is the key thing here. And that's what we're looking at using CE inline and display, right? In fact, I can even copy this. I can copy this. Okay, it's already there. So I can just copy this and put a comment in front of it so we can see what we're really doing. So I just bring this whole thing now. Okay. Then I bring it to, I think I want to keep this somewhere. So I bring it here under hello chemistry, of course, not after begin documents or not after end document. If you bring it after end document, you won't see anything. So you have hello chemistry here. So maybe what I can do is I can use V space to, I'll just use 1 cm to really push it down as much as possible. So for inline, you have water is H2O, sulfate is S04, SO42 minus, ammonium is NH4 plus, and for display one, now you have 2H2 plus O2 equals 2H2. So this, this you balancing the is it oxygenation of hydrogen or something like that, and then it becomes water, if that's how it is called. So, and the equation is balanced like that. Okay. So that's so inline means maybe you want to just keep writing, like when you write equations inline, you just keep writing. But if you want the display to stand out, like you want to balance an equation, so you want to make it stand out, so that's display. Okay. You remember if you want to write inline for mathematics, what you would do would be to use single dollar signs. Or if you use double dollar signs, or you use backslash square bracket, open square brackets, backslash close square brackets, that would be for display, just like double dollar signs. And for inline, you either use single dollar signs or backslash open parenthesis backslash close parenthesis. So they do the same job. So here now it's just to use CE inline and all that. Okay. So here now we want to talk about states, charges, isotopes, and hydrates. Okay. So I'm just going like I've been doing too. Okay, I mean, okay, these ones they already have their stuff, so I don't have to write it like before. So again, I'm going to do V space 1 cm backslash V space. So I want to create like a vertical space so that we can see where the next set starts. So here now we have CeH2O liquid, CO2 gas. So you see H2O liquid, CO2 gas, NaClS like that. Maybe in between this ones, now I can now use say 0.5 cm to actually separate them. So I just do like 0. Maybe 0.2 should be good. Okay, 0.2 looks like a lot. Okay, it's fine now. So I'll just use that in between the new things I've copied to just to separate. Okay, so we have H. So by using this backslash C now, so we have Fe3 plus. So first of all, we have H2O liquid, CO2 gas, NaCl solid. H plus is aqueous, right? That's in chart form. Then you now have isotopes now. So you have carbon 14. I think there are two isotopes of carbon. I think carbon 14 and 16. I'm not sure. Then I think this is uranium 235 92. Then we have hydrate. So in that case, hydrate dot, we have mchem passes as backslash C dot in formulas. So you just have backslash C, CuSO4.5 H2O. So you see, you just write the numbers directly, but everything is properly formatted by the time it is rendered like that. So, so we go for the next one. I'm going to do another vertical space of 1 cm. So we go for the next thing. So that's talking about states, charges, isotopes, and hydrates now. Then what about reactions, reaction arrows and conditions? So, some reactions can be forward or backward or both ways. So that's what reaction arrows will help us take care of. So I just copy this now, bring it over here. Okay. Then of course, maybe create this 0.2 cm spacing in between the two like that. Where is it now? Okay, I mean, they even stand out, so I don't have to bother. So you see, for A plus B, I go to C, then A goes to B and B goes to A. So like this. So, and how do you make that happen? Of course, you have this normal display thing that we use in mathematics. Then now have CH3, CH2O plus O2, and that leads to, so you have, that leads to delta. Okay, I think. Yeah, I mean that for the first line, we have this one, sorry. So we have A plus B goes to C, A goes both ways to B, and this is strongly forward. So A goes strongly forward to B. So it can go both ways, but it goes strongly forward to B. And that's what we have right here. And for the next one, so you can have annotated arrows, like you have above and below labels. So for this reaction that is good, this CH3, CH2O, H plus O2, that is going to CH3CHO plus H2O now. So you have PT at the top and you have delta under. Maybe talking about some change in maybe some energy or something like that. So you have PT, you have the delta down here. So you have this, and then you have HV here, and to do HV, so just have H slash nu at the top. So if you have the first one automatically goes to the top, the next one goes down. So if you want to use this for chemistry, you're good to go for sure. So then we move on to the next. Okay, first of all, we can do the 1 cm arrow thing just to create some spacing. Okay, create some spacing. So next we go on to fractions and electrons. So let's look at some stoichiometric fractions, electrons, and redox. Or is this stoichiometric? I'm not sure what that is called now. Stoichiometric. I believe that should be what it should be. So we pull this down now. So we have, because we need to work with fraction, and we have C half O2 plus 2Ag equals Hd2O. Then Q quad, I mean, that's just going to create some space. And we have CEMNO4. So we already have it rendered now. So you see, half 02 plus 2 Ag equals Ag2O, MnO4 minus plus H4 plus 5e minus equals Mn2 plus 4H2O. So that's talking about stoichiometric fractions, electrons, and redox. That's reduction. What's redox again? Reduction oxidation reaction. Yeah, I think I remember that a little bit from my rusty chemistry. Okay, so we have equilibrium and rate expressions in CE. So you have equilibrium kinetics, upright symbols via math. So we use math RM here now. So let's see what this does for us. Okay, equilibrium kinetics, upright symbols via math RM. Let's see how that works out for us. So here you have C K math RM. So that's K underscore C now, and that's C. Then for frac NH squared N2. So let's see how it's rendered to see. Okay, now you see, I think this talks about concentration and all that. What is the title again? Equilibrium and rate expressions. Okay, like some kind of rate of reaction. So you have K underscore C. This math RM gives you the underscore part, and then frac. So you have NH3 squared. So NH3 squared inside that box like that, all over N2H2, H2 raised to power 3. So talking about the concentrations also. And you have R equals, so for this other one, you have C equals R equals K, A power M, B power M, like that. So that's talking about equilibrium and rate expressions. Then you have equilibrium and rate in standard math. So if you don't want to use, you just want to use plain maths when you don't need CE parsing. So if you don't need CE at all, you can use standard mathematics to still make sure you get what you need to get. So \v space 1 cm. Okay, and we go for this. So we just use plain math. So you just use the normal display math. K underscore P equals K math RMC, RT raised power delta N, Q quad, Q math C, blah, blah, and see how that is rendered. So for KP, this is what you have here. And then K underscore C, that's K \math RMC. Then you space it a bit. So you have RT raised power delta N, as you can see there. Then you have Q quad, that's just to separate it. Q quad is what is giving you this big space. For you to understand, if you don't do Q quad, if you make it just one Q, the space shrinks. So if it runs now, you see this space is going to shrink because we use only one Q. Yeah, you can see the space has shrunk. Then if you want to even shrink it further, you just use backslash and comma. That's backslash and comma. The space becomes even smaller. So yeah, see the space is smaller. So you can use this. You can use Q quad. I mean, you can use quad, right? This expands a bit like that. Good. Or you can even make it bigger by using Q quad, and then the space expands even more than what you have here. Okay. All right. So you see QC is product of all the products raised by new, and all of our reactants raised by new. So you have all of that going on right there. So see, you have backslash. So for QC now, which is the other side, this other side, you have backslash prod. So that prod is that thing that looks like pi or ladder. So backslash text products, raised power new and all this. So again, I do v space 1 cm to give some vertical space. So conditions with units, siunitx plus mhchem. So that's talking about if you want to put things like temperature, pressure over arrow, Haber, or is it Haber? So see what happens right there. So temperature, pressure. So you want to indicate temperature and pressure in your reaction. So you have, say, N2 plus 3H2. It can go back and forth. You have SI 450 Celsius. That's temperature now. And you have SI is standard unit now. 200 bar, that's pressure. So you have temperature and pressure here. So N2 plus 3H2 under 450 degrees centigrade and 200 bar, that's pressure, gives you two moles now of NH3, right? And then down here for the decomposition heat, so the heat to decompose CaCO3, in solid form, the heat now is the delta. It's then it decomposes into calcium oxide in solid form and CO2 gas. Okay, so you have CO2 gas liberated in the presence of heat. Okay, so we have, what if we want to work with units? Units with \SI. Another thing we could have used is \PU, but I mean that was really problematic here. So that's why I didn't bother. That's why I just changed everything to SI. But you can use PU too. I've not. I guess it does basically the same job. So you don't. I don't think you're missing anything if you use just \SI instead of \PU. So again, I'm doing this space 1 cm. Then I bring this down here. Okay, so it says the concentration is 0.10 mole per liter, the volume is 250 milliliter, and the temperature is 298 Kelvin. Alternated, that's 0.10 mole per liter, 250 ml, 298 K. So you see, how do you pull that off? The concentration is \SI 0.10. Then in another embraces, now you have \mole, \par, \liter. So \mole, \par, \liter is what gives you this mole per liter, in the proper form. Then the volume is SI 250 milliliter, right? So \milli, \liter, and that's why you get this 250 ml. And then Kelvin, for Kelvin, you have \SI 298 \Kelvin, and then it gives it to you in this proper K form that you have right here. And that's exactly what you have down here. Alternatively, so let's see if you still have something else. I have this space 1 centimeter. Then let's see what we have again. So what if you want to align multiple equations, right? So so you can do begin align and end align. If you want to number the equations, you can also number it, just like what we do in maths normally. So in this case, now use and to align. This and are for alignment. Then you have all the C2H5OH plus 3O2 going to C02 and all that. So this is exactly what we have here now. Okay, so you can see you align the equations using the and signs. So you have all these things. So you can have equations being aligned like that. Okay, so I go again for the next one. So if you have more than one equation and you want them to just come out together, you can do that using for this chemical equations. So what if you're working with organic and radical organics? Maybe you're doing some organic chemistry and you're working with radicals. So that also goes. So you have \. So this is more like we know that is display. So this \ braces, or you can use double dollar. I think we've not used double dollar since. So let me use double dollar here. So you can just say that. Okay, Control Z. Okay. Where does this end now? Okay, let's even see how it is rendered first of all. So you have CH3, CH2, CH3, so all the connections and all that. So this whole thing is a display up to HCl. So what I'm just going to do is, instead of this now, just put $2. Okay, and this goes. Then here again, I have $2, and this can go. So it's still the same thing. That's exactly what I just want to describe. So if it is re-rendered, it's exactly the same thing. So it's just like what we do in math. So you either use double dollar for display or you use \. So you see these two are different things. Now that CL2 part is different. So let's do this space for this and do maybe just 0.2 just to space it out, 0.2 cm, So for this one we use double dollar, for this one we use \ brace. So this is radical dot not CL in this case now. So this is radical dot So Cl2 equals 2Cl. Another HV thing. H no. Okay. So what about common annotations cheat sheet? Like maybe you want to talk about catalyst, heat, light, solvent and acid, gas precipitate marks and all this. So this is what you just have here. So \C, then the arrow goes to the precipitate, delta for heat, as we've been saying, then and so on. Okay, so again, I do \V space 1 centimeter, and then, okay, control V. So I paste all this. So you see \C. So that CE is like the big deal when it comes to working with chemical equations. What has happened here? Nothing is, oh, okay, I was wondering. Okay, so you have catalyst, PT, heat, you have it there, light. Okay, so it means that Cl2 in the presence of light turns to 2Cl. That's what this is about. Okay, this is catalyst. I think we saw catalyst somewhere. So we saw a PT somewhere, I think. I believe we saw PT somewhere. Okay, we didn't see, I thought I saw PT somewhere. Okay. Okay, no PT. Oh yeah, yes, there's PT here. So this CH3, CH2, 0H, when when it reacts with oxygen, in the presence of catalyst and heat, it turns to water and CH3, CHO, like that. And then this one is light. HV, I think, is light. That's what we see. Yeah, HV is light. So it means that in the presence of light, CO and Cl2 turns to COCl2. Okay, so we have solvent and acid. That's H2SO4 aqueous. Then we have gas out. So CO2 is released. And we have precipitate, like, like something that settles inside the liquid. So it's precipitate. That's this AgCl. That is it silver chloride or something. Something like that. So now, what you can also have a tiny reference talking about species, state charges, and isotopes and all that. I mean, this is not the mini project. We're still going to have the mini project separately. So, I mean, you can do a whole gamut of chemistry stuff using LaTeX, and that's beautiful. So you can, if you've been wondering, you want to make you're into chemistry and you want to make your thesis exceptional, you can use LaTeX, especially now that you know that you can write your chemical symbols using in LaTeX. Once you can master, so just a few things, \C, \SI for units, and then the other things you need to do. So you see this whole thing now. So some of the things we've been doing. So for the temperature now you have \SI 25 \Celsius. For concentration, SI 0.100 per mole, \mole per/liter, all in braces and all that. So maybe I should do some vertical space in here. So first of all, you have this. Okay, it's like everything we've been doing in short. It's like everything we've been doing. So let me do vertical spacing like 0.2 in between each of them. So 0.2 cm. So I have this. Then I bring this here. Then I bring this here. Then I bring this here. Then I have this here. Yeah, and that's about it. Yeah, so we have it all separated. So you can work with all of these things. So for all the power, you just use caret. So C with normal open and close square brackets, then power C, power D, \. So, I mean, you can do chemical stuff all the way. Okay, so let's talk about the mini project now. So that one is just, we have everything we've been talking about, we have all of them together and so much more, So we have mini projects like a reaction toolkit. So you want to produce a single page PDF summarizing 6 archetype reactions: acid base, precipitation, gas evolution, redox equilibrium synthesis, thermal decomposition with annotated conditions, and a compact box of formulas, rate law, Kc, Kp, units, and all that. So I'm just going to copy all this out and we'll see how the whole thing goes. So I copy the LaTeX script. to render all these things. Okay, I mean, I'll just keep copying, and whatever we see, we just take it. So now, instead of overwriting, okay, I can produce this, right? I can generate this, what we've been doing so far. So the whole chemistry stuff we've been doing, see all of that, hello chemistry. So, I mean, if you're a chemist and you want to explore LaTeX, feel very free. Maybe you are frustrated with Microsoft Word, using Microsoft Word to type LaTeX stuff. So here now, so that was Chem 1, right? I just want to create another file and I call it Chem 2. Okay, I'll create that. And then I just paste that whole thing, with the whole mhchem siunitx per mode the symbol, separate, uncertainty true, round mode, blah blah blah. I have all of this. So it's telling me it's taking time, but it's okay, it still renders, which is all we need. So you can do the whole author thing. Yeah. So I author now, I'll give myself the title of a chemist. Dansu the chemist. Let me say that. Then date, I can say today. Okay. And then we have this whole thing. Working with chemical equations, a one-page toolkit in SI unit. So Dansu the chemist, November 11, 2025. So we already saw how to do all this. So we have quantities and units, SI units. So we see amount, concentration, mole per m cube. And how do we do that? So SI mole per cubic meter, mole per cubic meter, backslash mole backslash per backslash cubic backslash meter. Okay. Then we have pressure, often kPa or MPa, temperature K. So you see how all of that is done. Megapascal, kilopascal, then ordinary pascal, volume, cubic meter. So you just need to know the standard thing. So typical reporting is you have typical reporting 100.000 mole per m cubed to 20.000 megapascal, 298 Kelvin, and all that. Now for representative reaction, so you have things like acid-base reaction, acid-base neutralization. So you have the HCl acid, NaOH base, and then it gives you salt and water, basically. So, and you have sample data like these ones here. So how does that happen? So you have, for acid-base neutralization, so it's display form. So you have this, and then you have the sample data. We've seen it a lot. Then for precipitation, you have AgNO3 and so on and so forth. And you have this, the way it happens right here. Then you have the gas evolution. You have redox reaction. This is reduction oxidation reaction right here. So here it looks like H is oxidized and manganese is reduced or something like that. So you have H2O released and you have all these ones. You have ferrous, is it ferrous 3 or something like that, forgotten what we used to call of this in chemistry back in the days. They have equilibrium synthesis, N2 gas plus 3H2 gas under this temperature, 723 Kelvin and 20 megapascal. So it produces 2 moles of NH3 like that. So that's NH3 squared over N21 H33. So this is one way to write that. And then you have something like this. So the delta N is 2 minus 1 plus 3. That's -2. Okay. So it's like -2 would mean that heat is given off or something like that, if I remember my chemistry very well. So, I mean, you have these all possibilities right here. So LaTeX can help you do so many things as a chemist. So you can, practice some things. Add conditions over the arrow for nitration of benzene with HNO3 and H2SO4. So you can practice some of these things so you can actually be sure you really understand what we've been doing. So mini checklist, use SI for all numbers with units, prefer mole per m cube, Pascal, K, and m cube. Then put all meters, all species and arrows inside a \C. Then place SI conditions above or below arrows. Then keep significant figures consistent with data quality. For K, Q, and rate loss, typeset exponents and brackets clearly. So, I mean, just follow everything we've been doing. That's all this is about. So you can do your own mini project. Typeset one reaction from each class above. Add SI conditions, e.g. Temperature, pressure, express concentration in mole per m cube. Include, create a half-page lab template, pure SI that typeset, adds, includes one work stoichiometry line using only SI in it, shows one KC expression, and if gases are present, relates Kp and Kc via delta N with R equals 8.315 joule per mole Kelvin. Okay, so I mean that's beautiful. So we can generate this as a PDF document. And that's LaTeX, they're doing all the chemistry. And that's so interesting to know that LaTeX has got you if you are a chemist. So I think we have a few things to tidy up before we move on. So troubleshooting now. If C is undefined, you have to add use package version mhchem. So I mean this is like the most important thing when you're working here. All right, so use this package in the preamble. Charges must be superscripts. So superscript use caret. Usually my caret is on top of 6, so superscript. You don't just write FE3 plus. That's to be FE raised to power 3 plus 3 plus will be together, not just FE3 plus. Let's write FE3 plus and see what it looks like. So I'm just going to write that somewhere. So I just want to see what FE3 plus looks like backslash CE, and then I have FE3 plus. So let's see what that looks like. So I know it's going to be like maybe FE3 will now go on there, most likely. Okay, it doesn't even show. Okay, it's still, yeah. So the 3 goes down and plus goes up. So because it's superscript now, the way FE3 plus should be written, so in case you don't see that well. So see what I did here. So the 3 comes down. So, but if you want it to be superscript, so you have FE. If you just do raised to the caret like this, the 3 goes up, but the plus stays down, and that's not what we want, right? So you want FE3 plus. You should put that in braces so everything can go up together. So that's how it should be. Okay. Then keep species, states, and charges inside C to avoid italics and spacing issues. Then prefer \p or SI for units. I like SI for units. Avoid manual spacing like 0.1 m. It doesn't work. So just use the standard thing. So, and that, of course, the mole is \mole, and you type it out all like that. And with this, I think this is really interesting, working with chemical equations and LaTeX. So if you're a chemist or you do work with chemical equations, you're good to go with LaTeX. So with this, I come to the very end of working with chemical equations, and most likely that's working with chemical equations and LaTeX, and most likely this playlist on LaTeX, except something else comes up and maybe somebody makes a request and I need to do something I've not done already. Thank you so much for coming along with this journey. Let me know how helpful this is for you. And if there's something else you'd like me to do, feel free to let me know. If you have subscribed already, I thank you very, very, very much. If you haven't subscribed, why not? Go ahead and subscribe right away. Hit the notification bell also so you can always get alerted each time a new video is released. Having done that, you can take it a step further by becoming a member of the channel. And there are 3 levels of membership with special privileges. So feel free to avail yourself of the opportunity. At the highest level, if you're I have bronze, silver, and gold. If you're a gold member, we can hang out physically if you're in the same location at any point in time, or we can hang out online, to talk about anything I do on my channel, be it maths, be it data analysis, data science, machine learning, scholarships, and so on and so forth. We can talk about any of the things I get to share on my channel. Thank you so much for listening. Don't forget to comment, like, share, so that more people can have access to the great content I have going on. Until I come your way again, keep doing life right. Not just LaTeX or maths or data analysis or data science. Do life right. Bye.